Okay, for today's lesson, let's do a quick recap. This was what we covered the last time. Angles on a straight line, they add up to be 180 degrees. So in this case, these three angles, angle C plus D plus E, they add up to be 180. So whatever the values are, and we call this adjacent angles on a straight line. Then similarly, for angles at a point, we learned that angle W plus X plus Y plus Z, because they form one complete round, they all add up to be 360 degrees. So this is what we will write: W plus X plus Y plus Z. This gives us 360 degrees. The reason is angles at a point. Okay, now next one. Today we will check out something else. If we have a straight line as such, then we draw another straight line over it in such a manner. Then let's call this angle as A. So let's say we use a protractor and we measure this value, this angle A over here, and we find that it has a value of, let's say, 40 degrees. Now can you think about what angle B over here is equal to? So note that A and B, they lie on the same straight line. So we will be able to calculate the value of B by using 180 degrees minus our angle A, which has a value of 40 degrees, to give us 140 degrees. Okay, now the next part, I am actually interested in this angle. Let's call it angle C. I want to find out this value. Turns out, angle B and angle C, they lie on the same straight line. So I am able to find the value of angle C by doing something similar. I take 180 degrees and I minus away angle B, which has a value of 140 degrees. So leaving me with just 40 degrees. And we notice that this angle A, 40 degrees, is the same angle C, 40 degrees. So no matter how I change the value of angle A, it will result in a change in our angle C. So for example, if I were to change this 40 degrees to become 50 degrees, then my angle B will also change. So 180 minus 50 degrees, and I will get 130 degrees. So once angle B is 130 degrees, to find angle C, we change this to 130 degrees. And when you do the subtraction, you will end up with 50 degrees. And you see that angle A is still equal to angle C. So in summary, if this angle A has a value of, let's say, 30 degrees, then I know that this angle C also has a value of 30 degrees. They have the same size. If this is 48 degrees, this will also be 48 degrees. So it is shown over here. Whenever you have one angle on one side, another angle vertically opposite, we call this vertically opposite, they have to have the same angle. Okay, so as shown, vertically opposite angles are equal. So not just these two, let's call it A. This will also be A, not just these two. Vertically opposite angles also include this, B and B. So as long as you see two lines forming a cross, these two are vertically opposite, these two are vertically opposite, and they have the same size. The next portion is to find the size of a reflex angle. So remember our weekend homework was to take photos of angles at our house, and I noticed that we had the least photos for reflex angles. Okay, recap again. Reflex angles are those angles that are greater than 180 degrees, more than a straight line. Somehow it seems that you couldn't really find reflex angles at home, but actually reflex angles are also everywhere. For example, if you found an acute angle, then what is on the other side? This is a reflex angle already. If you can find a right angle at home, then this is a reflex angle. If you can find an obtuse angle at home, then you also have a reflex angle here. So now our protractor can't really be used to find the reflex angle ABC, which is this one, because this angle is greater than 180 degrees and our protractor only has up to 180 degrees. So we're going to use a little trick. That is, we use our protractor to find this acute angle. Use protractor to find. Once we manage to find this value, all we need to do is just subtract this from 360 degrees. Okay, so it is shown over here. You find this acute angle. Turns out it is 40 degrees. Then, knowing that angles at a point, the total is 360 degrees. We just need to do a subtraction. So 360 minus 40 to give us 320. So this is what it looks like. The entire circle, 360 degrees. This green portion is our acute angle of 40 degrees. What we actually want to find is the remainder. So the remainder must be 360 minus 40 to get 320 degrees. So in try it 4, we can see that the obtuse angle PQR. Obtuse angle PQR more than 90 but less than 180. We can use our protractor to find this. But the question wants reflex. Reflex is here, whereas this is obtuse. So for this, use your protractor to measure. Once you have the value, the reflex angle PQR is just 360 minus that obtuse angle, whatever you measured it to be. And you get the answer. So your homework for the rest of this week is in your workbook, page 6. So just 2 more questions. Question 4, A and B. Alright, I will give you a hint for question 4A. You are asked to find the size of the unknown angle, meaning this one over here, angle C. So you have to look out for the cross, where we can use our vertically opposite angles. So if I just highlight the line PQ, and I highlight the line RS, can you see that they form a cross? So with this cross, the angles on the opposite sides are equal. So this 145 degrees is vertically opposite this other angle, which means that 145 equals to 48 plus C. Or we put it the other way around. Let's put the unknown at the start. C plus 48 equals to 145 degrees. So state the reason. The reason is vertically opposite angles. And now you can find the value of C by subtracting something on both sides. Okay, so what should you subtract? You think about it yourself and get the answer. So the other hint, this square over here refers to 90 degrees. It is a right angle.